Okay, today we will be talking about rotation. This is the second kind of transformation that we will be discussing. So if we look at this one, there's an example of a real-world situation where you would ride a Ferris wheel. When we talk about the angle of rotation, we want to look at this yellow car here. And we're going to rotate it clockwise, which means it's the same direction as a clock. So if I rotate it the same direction, it went from here to here. In order to find the angle of rotation, you connect the original point. Let me change that color. The original point to our image, and whatever the angle is our angle of rotation. So if I look at that angle there, that is a 90-degree angle. So the angle of rotation was 90 degrees, and you always have to put clockwise or counterclockwise. This was for clockwise. So if I reset that, again we said it was 90 degrees clockwise. Because if I do counterclockwise, then it moves it in the other direction. So be careful on counterclockwise and clockwise. Okay, so if I have this and I label my original point as A, the center of rotation as O, and my image as A prime, we would say that that angle is 90 degrees. Okay, our second example here does something very similar, but it's a little bit harder to measure the angle, so we're going to actually use a protractor. So to fill in what we need to know is we know the coordinates of R is at 3, 2. And if we go ahead and we rotate that to its new location, R primed is at 2, negative 3. The direction of rotation, it went clockwise. And the angle of rotation, in order to get that, remember you have to connect the point to the center of rotation, which is rotating around O, to the image. You have to do it as accurately as possible, and then you measure your angle. So I'm going to go ahead and I'm going to get this protractor lined up correctly. Put the center where it goes, lay that on the 0 line. And so if I look there, this angle of rotation, let me make this smaller so I can actually see, would be about 92 degrees. So you can see, if you aren't accurate with drawing these lines, that it might be off by a couple degrees or so. Okay, here is your joke for this section. What do you call a crushed angle? Go ahead and write your guess down on the guided practice sheet, and I will look it over and check it over when I check your notes. So again, the joke is, what do you call a crushed angle? Okay, back to work then. We have a clock here, which is a very easy example of rotation that we see on a daily basis. So here it's asking, what is the center of rotation? The hands on the clock rotate about the center of the clock. So the center of rotation is the center of clock, and it's called the clock face. Okay, so if I go ahead and I rotate this, it went from the 12, the hand went from the 12 to the 1. So we have to figure out the angle of rotation. So if I go ahead and I draw in my line, Okay, let's say I don't want to use a protractor. The reason I don't have to on this time is I know there's 360 degrees in a circle. So all the way around the clock face would be 360 degrees. Well, this is split up into segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So like 12 pieces of a pie. So if I take 360 degrees, divide that by 12, that gives me each segment is 30 degrees. So if I go from the 12 to the 1, that's one segment of the clock, so my angle of rotation is 30 degrees. The direction of rotation, we went from the 12 to the 1, so that is clockwise. Just a review of some vocabulary, an invariant point is the point that remains unchanged. So the invariant point is the point that remains. You can say unchanged, you could say in place, however it makes more sense to you. So then, in this case, the invariant point under this rotation is the center of rotation, because the center stayed the same. It went from here and then it just turned over, but that remained the same. Okay, so now we're going to apply this instead of real-world applications to what it would look like in a coordinate plane. So it says P is rotated to P primed about the origin. So this is your center of rotation. State the angle of rotation. So in order to do that, remember we connect our points through the center point. So P to the center, center to our image P prime. We try to be as accurate as possible. You can use a protractor to measure, but by looking at this, the angle of rotation is 90 degrees. The direction of rotation, I went from P to P prime, so that is counterclockwise, which is CCW for those of you that like to use shorthand. So counterclockwise, CCW. My invariant point then is not applicable, because there wasn't a point that remained unchanged. These were not line segments. The original was just the points P and P prime. The other thing I want to point out, if we call our center of rotation O, what would be true about PO and P prime though? They would be congruent, because the original and the image are equal distance from the center, because they're basically going around the rotation in a circle. So if I look at B then, the same is true for over here. So the center was our point of rotation, so it went from P to our center of rotation to P prime. So if I look there, here is our O, which is our center of rotation. The angle of rotation, a straight line, is 180 degrees. The direction of rotation, if I turn 180 degrees counterclockwise or 180 degrees counterclockwise, it gives me the same location. So the direction of rotation is either clockwise or counterclockwise. 180 degrees is the only angle at which you can rotate something and go either way and end up in the same place. So generally, when we have a 180 degree rotation, we don't put counterclockwise or clockwise because they mean the same thing. Again, the invariant point is not applicable because we only have points here. We don't have line segments touching our center in the beginning. Okay, our guided practice number 1 is right here. You need to answer A and B. Guided practice number 2, you need to state the following: the center of rotation and the angle and direction of rotation, and you get that out of your book. So if you look at section 8.3, guided practice number 2, you'll get those answers there. And your assignment is page 83 through 84, 1 through 3, and number 8.